Hello everyone, this is question number 30. These questions belong to theory of competition. In pumping lemma for regular languages, to say language is satisfying pumping lemma, what is the minimum length of y if you consider the string xyz? Here we have the string xyz and we have to determine what will be the minimum value for the length of y. So I am asking you a question. If I am saying that there is a variable called a and I am putting a condition over a that the length of a would be greater than 0. So what would be the minimum length of a? So you can say the minimum length for variable a will be a equals to 1. So 1 will be the minimum length for variable a. So same technique used here when I am saying that there is a string called xyz in pumping lemma, what will be the minimum length for y? In order to answer this question, we must know the three basic properties of pumping lemma. Here let L be a regular language. So here we are determining there is a regular language and we are representing the length of the regular language or the string by the word w. Then there exists a constant c such that for every string w in L, so for there is a constant called c, so I can say that length of any language would be greater than 5. That means total number of variable in a string would be either greater than or equals to 5. So here I can say a, b, c, d, e. So here the length of a string is equals to 5. 5 is a constant variable here. So how we can determine the mediocre value, which is the y? So we can break w into three categories. So here the combined string we will represent like xyz, so such that the y greater than 0. What would be the y? Y will be the mid value of this string and that would be greater than 0. Here x and y, so the x and y that would be less than and equals to c. C is the constant value, and for every k is the multiply of the y, that how many times y occur in any string. So k must be greater than equals to 0. That's why I am saying that the length of the y would be greater than 0. This condition must satisfy when we are dealing with the pumping lemma. So for L, k greater than 0, the string x, y, z is also in L. Obviously, when all those things belong to the same string, then this value and the value of k will be belongs to the same string as well. So here, in order to answer this question, we must aware of the pumping lemma and the string and how the properties are using in this pumping lemma. So the correct answer for this question will be option number 3rd, where we have the minimum length of y, that is 1.